second quadratic equation for this quiz. And this time we have our quadratic equation written as the factors of whatever the equation was, right? And these two factors are multiplied to equal 0. And we know that when we have two factors multiplied to equal 0, we could use our zero product property, which tells us that if the product, the answer to the multiplication problem, is 0, then it must be that one of those factors was 0. So it could be x plus 3 was 0, and then we'd have something true because we'd have 0 times something, whatever this is, equals 0. Or it could be that x minus 9 is 0, and 0 times whatever this is equals 0. So we're going to use those two possibilities and create two equations. Okay, so we have either x plus 3 is equal to 0. When x plus 3 is equal to 0, we have something true. When x minus 9 is equal to 0, we have something true. So these two equations are going to give us the two different solutions for x. So we'll subtract 3 to get 0. Subtract 3 on the other side, and we have x equals negative 3. We'll add 9 here, add 9 on the other side. We have x equals 9. So our two possible solutions are x equals negative 3 or x equals 9. I'm going to move right on to the third question in the same video. Okay, so now let's see. Could we use the same strategy that we used before where we had factors equal to 0? Let's see, if I would subtract 4 and get this equal to 0, I would have x squared plus 8x, and then 3 minus 4 is negative 1, so minus 1 equals 0. Is this factorable? Well, in order for this to be factorable, we have to have two numbers that multiply to negative 1 and add up to 8. The only factors of negative 1 that I know of are negative 1 and 1, which do not add up to 8. So we're not going to be able to write this as two factors. So we can't use the zero product property that we use in the other one. So in the next video, I'll show you which rule we will use for a problem like this where we couldn't factor and we need a different